Hi, in this video we're going to look at the basic elements of an electrical circuit and the characteristics of it, and then we'll take some measurements. Okay, so here is our basic circuit. The basic circuit, minimum 3 components. We have got our power supply, we have a switch for control, and then we've got a load, or in this case a resistor that we're using for that load. Okay, the characteristics that we're going to be looking at and we're going to be talking about for this particular one are voltage, current, and resistance. Okay, so if we just talk about those for a moment, voltage is the electrical potential difference between 2 points in a circuit. We see it as the force in the circuit that pushes the charge or the electrons around through the conductor. Okay, voltage is measured in volts. The current is the actual flow of the charge in the circuit, so it's the movement of the electrons around through the conductor, through the wires that we have in the circuit, and we measure that in amps or amperes. And then the third element then is the resistance, and resistance is, I suppose, the opposition to the flow of electrical current in the circuit. It's what slows down or ultimately stops it within the circuit. Resistance we measure in ohms, and we use the omega symbol for that. The relationship between the voltage, the current, and the resistance is defined for us by Ohm's law. So as you can see there, voltage is equal to the current multiplied by the resistance. These are the three fundamental elements in our electrical circuit. The fourth, I suppose, fundamental that we may have a look at later on is power. Okay, but we'll stick with voltage, current, and resistance for the moment, and we'll have a look at a circuit on a breadboard here, and we'll measure those as well. But just to get some of the concepts and the ideas across as to what we have going on here. So when we talk about voltage, as it mentions there, it's a potential difference. It's always measured between 2 points, and it's the difference in potential between those 2 points, or the difference in the amount of force available at those 2 points, if we wanted to put it like that. So if we take a voltmeter, so I'll just put my voltmeter down here, okay, and we connect up the red lead here to the positive side of the supply, and the black lead to the negative side of the supply. Across that supply we will see the potential difference of the supply, or the voltage across that supply. Okay, for the little experiment I've set up here, I've set mine up so that it'll be 5 volts there. So the 5 volts of a difference between essentially the red lead and the black lead on the meter, or between the positive and the zero side of the voltage supply that we have there. Okay, and it's a DC source we're using in this one. Now, there's a few things that we want to talk about then. So with the switch open, okay, no current can flow through the circuit because we've got what we call an open circuit, and therefore the electrons have no path to flow. The switch in the open condition here essentially shows us a very large resistance, and that's why the current can't flow. There's no path for the current to flow through. Okay. When we look at the resistor up on the top, we can measure the resistance of that resistor. So we talk about the potential difference of the voltage, or the voltage drop across components. When we refer to resistance, components have a resistance. It's a physical property of the component. So for instance, that resistor there, R1, it has a particular resistance. The one I have on my circuit that we'll look at in a minute will be 100 ohms. So that will be a 100 ohm resistor. So we can measure the resistance of that, and I suppose for the most part, the components we're going to look at the moment, that resistance doesn't change. It's slightly variable to temperature, but essentially it won't change for us. Okay. To measure the resistance, we can take our ohm meter. Okay, and again, we'll put the leads of the ohm meter across the resistor like this. Okay, what happens in that case when we're measuring resistance like that is that the meter generates a small voltage and therefore sends out a small current through the resistance. So it knows the voltage it's generated, it measures the current that flows, and therefore it can calculate the resistance for us. Okay. It is important when we're measuring resistance in a system like this, it's very important to make sure that there is no current flowing through the circuit. So the switch must be open, or we must be disconnected or powered off. We can't measure resistance if there's already a current flowing through the circuit, because that interferes with our measurement. Okay, but if we come along and we close the switch, so we just disconnect our resistor there, or our ohm meter there for a minute. We'll take him out of there. If we come along and we close the switch, so let's just close the switch like that there for a moment, then we will have current flowing through the circuit. So current will, in conventional current flow, will leave the positive side of the supply, and it'll flow through the conductor, through the resistor, and then back down here and return to the negative side of the supply. I is the letter that we use, or capital I there, for current. And as it only has a single path to flow, the current all through the circuit here will be the same. So it doesn't matter where we would go along the circuit, the current will be same at every point in the circuit. Okay. We measure, as I said, voltage across components. We talk about voltage drop across components. Components have a resistance, and then when we talk about current, we talk about current flowing through the components. So the current will flow through the resistor here. Okay, and if we just look at our circuit here and we have a look at our Ohm's law, so V is equal to I by R, we can just manipulate that formula to get I is equal to V over R. For our particular circuit here, the voltage is 5 volts. The resistance we have, as I said, is 100 ohms, and therefore 0.05 will be our current, so 0.05 amps, which is equivalent to 50 milliamps. So that's the current we'd expect to see flowing through our circuit here. Okay, so voltage, current, and resistance, they're the key components that we have that we want to talk about. And we're just going to have a look here. Let me just switch on my camera. So on the breadboard that we have set up here, you can see that we have got our resistor just here. As I said, it's a 100 ohm resistor. We've got our switch here, which is in the form of a momentary push button. And we've brought our supply essentially from the bottom here. So this is where our supply is. I'm using a bench power supply connected up to the terminals at the top there. So let's just take some measurements here. So with the power switched off and the circuit dead, we're going to go to the ohms on the meter, and we're going to measure resistance. We'll just turn on the light there so we can see it a little bit easier. And then we'll put the test probes just on either side of the resistor. Okay, and you can see that the resistor there, it's 99.5 ohms, which is well within the 5% tolerance that we have for this particular resistor at 100 ohms. Okay, we can measure the resistance across the switch, and you can see, actually I have the supply switched on down here. Let's turn that off. So if we measure the resistance across the switch here, you can see that the meter is showing OL, or it's coming in there at 1.2 kilo ohms. We're just seeing the supply, I suppose, in that one. We just need to disconnect altogether here. Let me just pull that out. Okay, I'll just take him out of there. That's my supply. Sorry, now we're across the switch. Okay, we've got 1.2, or sorry, we've got OL. So OL on the meter means over limit. It means that the measurement that we're trying to take is beyond the capability of the meter to measure in that range. And the range we have here at the moment is mega ohms, so a huge resistance across the switch here. It's one of the things, I suppose, with our circuits that we need to be careful of, or to be cognizant of as we take measurement, is trying to understand what's in the circuit. So when I tried to measure my ohms here, so when I put my ohm meter here across the switch originally, I got 1.2 kilo ohms or something in that region there. Okay, now the switch was open, right? So I'd expect to see OL on it. But what actually was happening to me was I was measuring current back in this direction through the power supply, and back here I was measuring that resistance. Okay, which is I suppose an issue we can come across quite a lot in circuits like this. It is important that we break the circuit, we'll say back here, so that I don't have the power supply in circuit. And that's what I've done. I've just removed that cable just here. I've just disconnected that cable there. Okay, that's removed the power supply from the circuit, so now I can see the OL in the circuit. Okay, so I'm going to connect that back up again. We just pop him back into the rail here, like that. We're going to measure the voltage this time, so I'm going to switch on my power supply. And then we're going to go to volts, and as I said, we're measuring DC, so we're in volts DC range here. We can turn that light back on. It just auto powers off there if you're not taking measurements with it regularly. So in the volts DC there, I'm going to put these across the meter, across the power supply. So red lead to the red of the power supply, black lead to the black of the power supply, and you can see there we've got 5 volts, or very close to 5 volts. Okay. At the moment, if I measure the voltage across the resistor, I have 0 volts. That's because, as we can see here on the diagram, the switch is open. So when the switch is open, no current can flow, and therefore the voltage drop that I'm experiencing is across the switch. So if I just go either side of the switch here, you'll see across the switch I have my 5 volts. Okay, that's because the switch is open. When I close the switch, I'll be able to measure the voltage, and I'll drop the voltage across the resistor and measure it there. So let me just set this up here. So there's my meter across the resistor, as you can see. 0 volts until I press the switch, which will close it. And there we get our 5 volts developed across the resistor now. Okay. Ever such a small drop in the voltage there, so we've gone from 5.002 to 4.995, so we've dropped, what's that, 7 millivolts. That's a little bit of a drop just through the switch and through the circuitry that we have here. It's a very small voltage comparison to the supply voltage, so we essentially say that there's no voltage drop through the cabling. Okay, it's only 0.7% of a volt or something like that. Not even that, it's 0.2% of a volt or something like that. So we can say that essentially in the circuit that we don't drop voltage across the cabling for the ones we look at here. Okay, so we've measured the voltage across the resistor. We've measured the voltage across the supply. We've measured the resistance across the resistor. So the other measurement that we want to make then is just to measure current. Okay, but just before we measure current, we need to just talk about it a little bit here. So let's go back to the whiteboard that we have here. So when we measure the voltage here on the circuit, okay, what we do is we put the meter in here in parallel with the circuit, okay, and we just allow a small bit of current to flow through the meter here so we can measure that voltage. Okay, but in order to make sure it's a very small amount of current that flows through there, the meter in this setup here has approximately 10, not the small m, the large m, 10 mega ohms of resistance. So it's got a really large resistance, and that just allows a small trickle current to flow through the meter just so that we can measure it. Right? Therefore, we're not interfering with the circuit. When we want to measure current, so I'm going to try and measure the current just through the cable as we have it here. When we want to measure the current up there, we need to put the meter into the circuit. Okay, so what we do is we break the circuit. So let me just break my circuit a little bit here. I need to get up. I will go with this one here. Okay, that'll give me a little break in the circuit there, like that. Okay, going to come along then, and I'm going to stick my ammeter in here. Okay, and I'm going to take the red lead here and place it there, and I'm going to take the black lead and place it there. Okay, and now the current in the circuit will flow through the ammeter. If my ammeter has 10 mega ohms of resistance, it's going to change the current and drastically reduce the current flowing through the circuit. We don't want to do that. There's no point in trying to measure a circuit if we're going to reduce the current that's flowing in the circuit or change it in any way. So for that reason, when we want to measure current, the ammeter has to exhibit essentially 0 ohms of resistance when it's in circuit, so that it doesn't change the resistance, overall resistance of the circuit. Okay. To do that with the ammeter, or with the multimeter that we have, we just push it up here a little bit. We have 3 ports down here that we connect to. The black port is the common port, our reference port. In the right hand side over here, we have volts, ohms, and continuity test. When the leads are placed like this, there is 10 mega ohms of resistance between them. To go to current measurement, what we do is we take this lead out, the red one, and we pop it in over here in the ammeter port. Now, between these two terminals, there is 0 ohms of resistance. So this one allows me to measure current, and back over here then to measure voltage. The other thing we need to do is we need to switch the switch down here to the ammeter part. All right. Now, when we do that, I'll just do it here once more. You can see there the lead there, the meter flashes lead at me there for a second, and it beeps just for a second. It's just to indicate that I've gone to a 0 ohm resistance down here, and to be careful with the measurement I'm about to take. So the other thing I need to do then, I've set the meter up. The other thing I need to do is to set up the circuit here. So as I said, I need to break a hole in the circuit here. So we're going to move this resistor. I'm going to pop it out. Just use this sled here because you'd better see what I'm doing then. I'm just going to move it over here a little bit and pop it in there. So I've just got a little gap. Let me make that full screen there for a minute. Okay, I've just got a little gap between where the switch is here. I've moved over 2 rows to get to the resistor here. So I've just created that little air gap in there, or little circuit gap. And now what I want to do is I want to fill that gap with the meter. So we're going to go with the red lead at the switch here, and then the black lead in where the resistor is. Okay. So now I've just bridged the gap between the two of those with the meter. Now again, the meter is showing 0 amps DC there at the moment because the switch is open. When I close the switch, okay, you can see there we're getting the 0.050 amps or 50 milliamps, which, if you remember, was our calculation for what the current should be. Okay. Now, just to show that the current is the same in each part of the circuit here, I'm just going to break it in a couple of other places. But what we'll do first is we'll put this back where it was, just in there. We'll break it the other side of the resistor, just to see what's going on over there. So again, just a little 2-step gap here. And again, we will put the meter in, the red at the higher voltage, the black at the lower. Sorry, my hands there. Oops. In it goes there. Okay, again, we're just bridging the gap there. And again, we press the button here, 0.50. Okay. We'll do one more. So just take that out of there. Remake the circuit. And we'll just break the supply just down here at the bottom, just so that we can see it returning here. I'll place him up there for the moment. Okay, so again, we're going to go from here and down to the 0 line here. That's my meter in circuit. And again, we press the button and we get to 0.50. Again, doesn't matter where in the circuit, because it's a series circuit, there's only one place for path for the current to follow. So it doesn't matter where we place the meter, where we break the circuit, we should get the same reading. Okay, we just put him back there and tidy him up a little bit. Okay, and now my circuit is back working. We're finished taking the current measurement now. Okay, so as soon as we're finished taking a current measurement, it's really important that we take this probe and swap it back over to the other side. So let me just do that. Take this probe and pop it out. I'm not too interested in coming out there. Pop it in there, and then we'll go back up to voltage again. All right. We can just measure the voltage. Again, we'll measure the supply voltage. So between red and the black, okay, that's 5 volts. That's the supply because the supply is switched on. We'll measure the voltage across the resistor up at the top here. All right, and we have 0. Pop that back on there for you. We're 0 until we press the button, and then we allow current to flow, and we get our 5. Okay, I'll just release that button again there because we were slightly off to 0. There we go. Okay. And that's our circuit back functioning again. As I said, very important to move that lead back because, let me go back to this one here for a second. With the meter at 0 ohms, when we were measuring current, if we leave the leads in that position and then I switch back to voltage, okay, when I go to measure the voltage here, what will happen is my meter actually is 0 ohms. So when I put it in parallel with the supply here, it'll just short circuit across the supply, and will obviously draw a lot of current in there. We can damage the meter, or we can damage the supply, we can damage ourselves if we were doing it at a higher voltage than that. Okay, so it's really important when you're finished taking a current measurement that you go and make sure you put the lead back to the voltage setting, because that's the safer one. Okay, so that's our introduction to just a basic circuit, 3 components: the power supply, the switch, and a resistor, and the 3 key elements that we want to look at: voltage, current, and resistance.